Good evening. Hope you are fine. I'm safely or be safe. All right, please. Before we will continue, we do like say like and subscribe to this channel. So like this video so that the video can send to others who also needs help, and also subscribe to the channel so that whenever I upload a video, like you'll be notified automatically. Right? So today we are going to solve Managerial tutorial 33. Right? We are going to solve question 1, question 2, question 3, for question 4. We are not going to solve question 4. This is because we solved question 4 in the market structure video. So I solved it in that session. So I solved it getting into the later part of the session. So you can rewatch that video. You just watch the last ending and then think you'll be fine. Then we'll solve question 5. Right, we'll solve question 5. I know this video will be lengthy, but I think it will be worth it. Yeah. So I have eliminated question 4 so that the lengthiness of it will reduce because we've solved question 4 already. All right, so let's start. So basically, David, so question 1 says that you were a manager of Sompa, a major manufacturer of office furniture. You recently hired an economist to work with engineering and operations experts to estimate production function for a particular line of office chairs. The report from these experts indicates that the relevant production function is Q is equal to K raised to the power 0.5 L raised to the power 0.5. Remember, this is the production function. So this is the least, this is like what we will use to produce office furniture. This is like the function for producing office furniture. So basically, this production function for producing office furniture. So let's move on. Where K represents capital equipment and L is labor. Your company has already spent a total of $5,000 for units of capital equipment. Due to current economic conditions, the company does not have flexibility needed to acquire additional equipment. If workers at the firm are paid the competitive wage of $50 and furniture can be sold for 100 each, what is your profit maximizing level of output and labor usage? And there, what is your maximum profit, right? So this is a production function question. This is a production question. And this production question also includes cost in it. So production and cost. This is a tutorial set for production and cost. So let's quickly move on and then solve this question. All right, so let's all right. So now they're asking us to find uh, our profit maximizing level of output and labor usage. So what it means is that this question is asking us to find for value marginal products, right? Value marginal product of labor. This is because it is telling us to solve for or find the profit maximizing level for labor and then output usage. So before we can solve for output, we have to first solve for labor before we can solve for labor. Before we can solve for output, sorry. So basically, right. So now what we are going to do is that we are going to solve for marginal product of labor. Value marginal product of labor. The value marginal product of labor is basically price times marginal product of labor. That's the formula. It was shown, we spoke about this in the production video, so I don't really need to talk about this. So basically, for you to know for you to get your if a profit maximizing level of labor, you have to equate your value marginal product to the wage that is being received by the labor, right? So what it means is that value marginal product of labor is equal to the labor is receiving 50, right? So it means that P times marginal product of labor is equal to 50. Right. So now let me bring the production function. The production function is Q is equal to P raised to the power 0.5 L raised to the power 0.5. Right. So that's it. Q is equal to Q raised to the power. So we have to find marginal product of labor in this total production function, right? So if we want to find marginal product of labor, we have to differentiate Q with respect to L, right? So if we are going to do that, we are going to differentiate this. We are going to differentiate L in this. So if we want to differentiate L in this, we have to multiply everything. So we are going to get 0.5 K raised to the power 0.5. Then L now will be 0.5 minus 1. Right. So now the reason why we have 0.5 is because we multiply 0.5 raised to the power by the L to the whole thing. That's why. So now we are getting 0.5 K raised to the power 0.5 L raised to the power negative 0.5. Right. This is our marginal product. Right. Remember in the question, they told us that K is fixed at 4. Remember in the question, they told us that your company has already spent a total of 5,000 on the 4 units of capital it owns. So it means that K is 4, right? So now if K is 4, then 0.5 4 is the power 0.5 L raised to the power negative 0. Raised to the power negative 0. Right. So what this basically means is that so what this basically means is that 4 raised to the power negative 4 raised to the power 0.5 is given us 0.5 to L raised to the power negative. Right. So in everything we are getting L negative 0.5. That is what we are getting so far. Right. So this is what we've done so far. We found the marginal product of labor. Right. So remember that we are going to multiply price by the marginal product of labor and then equate it to 50 before we can get the profit maximizing level of labor. So now price here is the cost the price at which the furniture is being sold. The furniture is being sold for 100, right? So let's 100, and then the wage or the amount of money being received by the labor is 50. So let me write it here. P is equal to 100, and then wage is equal to 50, right? So now let's write this whole thing. P is equal to 100 times marginal product of labor. Marginal product of labor is L raised to the power negative 0.5. So L raised to the power negative 0.5 is equal to 50, which is the wage, right? So what is going to happen here is that we are going to divide both sides by 100 to make the L stand alone. So now L is the power negative 0.5 is equal to right. So still, we've not really gotten labor because labor is being raised to the power negative. So we have to find ways and means to eliminate this, right? And if we want to eliminate this, and we have to multiply here by 1 over 0.5. Sorry, to be negative 1 over 0.5. Then we have to do the same thing here. Times raised to the power, raised to the power negative negative 1 over 0.5. So this will cancel this, and then this negative multiplied by, now we are going to get L is equal to 4. You can put this in your calculator and then you will see L is equal to 4. So now the profit maximizing level of labor is 4 labors, right? Or 4 units of labor. Right, so let's move on. Right. So since the profit maximizing level of labor is 4 units of labor, and let's put this same thing, let's put labor equal to 4 in the production function, right? And then let's find the quantity. So this is the production function, right? That's the production function. So now Q is equal to, here we know to be 4, right? K is equal to 4, raised to the power 0.5. Now L2 is also 4, raised to the power 0.5, right? So now this is going to give us 2 times 2, right? And then it's equal to 4. So Q, the profit maximizing level of output is what? 4. Right, so we are getting Q is equal to 4. Right. So now let's move on. So what we are going to do here, now is the question we are done with finding the, so now let's just write something. Profit margin level output default for the profit margin level of labor support for, get it. Right, so now the other part of the question is that what is your maximum profit, right? So remember that to get profit, it's always equal to total revenue minus total cost, right? So we have to look for total revenue and then total cost before we can find our profit in this equation. It's equal to, right? So total revenue now here is P times Q, right? Price times quantity is giving us our total revenue. Where total cost is fixed cost plus variable cost, total variable cost, right? So okay, so here now P price here in this what we solved here is 100, right? The price at which the firm is selling is 100. And then the optimum and as a profit maximizing quantity is 4, right? And then our total fixed cost is 5,000. Since that's what the question said, the question was, your company has already spent a total of $5,000 on 4 units of capital. Its own. Due to current economic conditions, the company does not have the flexibility needed to acquire additional equipment. So this means that the equipment here is fixed, right? All right. So now the variable cost here is going to be the cost of labor, which is 50 times 4 units of labor, because the profit maximizing level of labor is what? Is 4 units of labor, right? So that's what we are going to do. And then we are getting 400 here minus we are getting 5200 here. In total, we are getting negative 480. So the firm is running a loss of $4800, right? So they can ask you, should the firm still produce whilst making this kind of losses? And then your answer should be based on that. You remember the shutdown situation, that if the firm profit no if the firm's price is at least higher than the variable cost, right? It's higher than the average variable cost. So the firm can what? Produce, right? The firm can still produce. So here is the case. The price here is 100. And then the variable cost is 50. The price here is 100. The price with the firm is selling is 100. And the variable cost is 50. The variable cost of labor is 50. So as far as the firm's price is higher than the variable cost, it should still be producing. Or also, if the firm revenue is able to cover its total variable cost, it should produce. So here the firm's total revenue here is 400, and then the total variable cost here is 200. So as far as this is the situation, still the firm can still produce in the short run, right? So this is it for question 1. This is it for question 1. This is it for question 1. Hope you really understood this. Right. All right. So let me clean the board, then we'll move on to question 2. Mm. Mm. All right, so question 2. Question 3 is saying that consider a firm with the following production cost function. Scale function of L and T, labor and capital, is equal to L raised to the power 0.5, T raised to the power 0.5, and sorry. The price of labor is 4 per unit, whilst the price of capital is 5 units, is 5 per unit. This firm has 20 units of capital and cannot change it in the short run. So this is basically telling us that capital is fixed. So now they say we should derive the cost function, right? We should derive the cost function, and then also we should derive the firm's marginal and average cost function. And also, what is the total cost of producing 50 units of output? And then also, suppose the firm is now free to choose any level of capital and labor to produce 50 units of output. How many units of capital and labor will it choose? What is the total cost of producing 50 units, right? And so we are going to do this right now. So now we know that total cost, first they are telling us to find total cost. A is telling us to find total cost. So total cost is equal to fixed cost plus variable cost. Total fixed cost plus total variable cost, and break it that way. Right. That's it. And then what they told us right now, they said, according to the question, K is fixed. So okay. So now total fixed cost is equal to R K. And total variable cost is WL. RK is basically the rate of capital, the price of capital. R is the price of capital, and then K is the unit of capital being used. Whilst W here is the wage of the labor times the labor, the quantities of labor being used, right? So now, in the question, they told us that labor is 4 per unit, and then capital is 5 per unit. So L is equal to 4, K is equal to 5. So this gives us 5K plus 4L, right? And then the question gives us that the firm has 20 units of capital. It cannot change them in the short run. So we assume we bring the thing to 5 is equal to 5, 20 plus 4. Right. This is giving us 100 plus 4. Right. This is going to be our total cost function. Right. But remember, before we can find marginal revenue, marginal cost, and average cost, we normally differentiate total cost with respect to fuel, right? And we don't differentiate with respect to labor, right? So what we are going to do now is we are going to look for L and then bring it here, and then we'll be able to get our correct total cost, right? So now let's move on. So remember the production function is what is the production? Production function is Q equals to L raised to the power 0.5 Q raised to the power 0.5. Right. And then they are telling us that K is fixed at 4. The K is fixed at 20. Alright. So now this is letting us get the production function of L 0.5 then 20 raised to the power 0.5. Right? So now what we are doing here is that we can either, so this is also equal to Q equals to 20 0.5. L 0.5. Right. So now remember we normally differentiate when we are solving for marginal revenue or average revenue, for example. For marginal when we are solving for marginal cost, right? What we do normally is that we differentiate total cost with respect to quantity. That's why we are coming. So now we are coming to make L the subject here and then bring Q inside the equation for us to get Q in the total cost function. So now this is going to be the divisible side by 20 is about 0.5. Or you can use calculator to do that. Use calculator to do this. 20 raised to the power 0.5 is giving me 20 raised to the power 0.5 is giving me 4.47. It's 472 and something. 4.47. So now for us to get this, so 4.47 divided by 4.47 divided by 4.4. 4.47. So cancelling out, we are getting L 0.5. The L 0.5 is equal to Q over 4.47. Right. L is still not standing, so you have to do something to eliminate the 0.5 to make it standing. So times 1 over 0.5. Remember, this time around it is positive, so it will not be negative. Right. So then here, so then we also divide 0. Is this followed by this? So this is cancelled. So L is equal to L raised to the power 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . 0.5 . Q raised to the power 1 over 0.5 all over 4.47 raised to the power 1 over 5. So basically, so when we do this, we are going to get 1 divided by 0.5 is 2. So basically, it will be L is equal to Q squared. Then we are also going to get 4.47 squared. So basically, it was 4.4. So we are getting approximately 20. Okay. So now L is equal to Q squared over 20. Right. So let's bring it back to this equation. So I'm bringing this here. Right. So now 100 plus 4 into bracket Q squared over 20. Right. So if I would simplify this to be 100 plus 4 Q squared over 20. Right. It's going to give me, still under simplification, 100 plus 1 over 5 Q squared. Right. So now this is the total cost function. We have to find ways and means to picture Q into this thing to get our total cost function, right? So now the question said we should do what? We just we derive the total cost function. So now the question is saying that we should derive the marginal revenue and average cost function. The marginal cost, so marginal and average cost function. Right. So marginal cost, let me just write to do marginal cost. MC is equal to differentiating TC with respect to Q. Right. So we are only going for this here. Q has a square, right? So this 2 times 1 over 5 is giving us 2 over 5. Right. Now it will be 2 minus 1 at the top here. So it's left with Q. So marginal cost MC is equal to 2 over 5 Q. Right. So now average cost. Remember average cost is equal to total what is this? Yes, average cost function. So average cost function is basically AVC, AACC, average total cost, basically TC over Q, right? And TC we had 100 plus 1 over 5 Q squared. 100 plus 100 Q squared. Now we are dividing by Q, right? So our average cost will be 100 over Q plus 1 over 5 Q. This is because 1 Q is already there. Right? So if it cancels out, you left it only 1 Q. So this is our average total cost. So 100 over Q plus 1 over 5. That is our average total cost, right? So let's get up to this point. All right, and then you have to answer. Right, so then the C part is saying that what is the total cost of producing 50 units? The total cost of producing 50 units. Remember, total cost. Remember, total cost is equal to total cost is equal to 100 plus 1 over 5 Q squared, right? So now we are saying that we are producing 50 units. So now it is 100 plus 1 over 5 bracket 50 squared, right? So 100 plus 1 over 5, 50 squared. If it's in numbers, we have 500. 1 over 5 times, I'm sorry, minus. So in total, this 100. So write some more English. The total cost of producing 50 units is $600, right? So that is it for and wait for the will be the C or the D part. That's the C part. So now they are saying that suppose the firm is now free to choose any level of capital and labor to produce 50 units of output. How many units of capital and labor will it choose? What's the total cost of producing 50 units? Right. So with this particular question, this is where we bring in MRCS, marginal rate of technical substitute. So it is the rate at which either capital or labor can be exchanged, right? So we can either use that or use Lagrange. So I'll talk about the two. No, I'll not talk about it. I will teach the two. And the rate one that it seems to be okay rate, then you use that one. For me, I prefer Lagrange because it makes a thing sensible to me. Marginal rate of technical substitute is also fine. It's also, I asked the lecturer and then he said all of them are accepted. So I think we are good to go into the method. So now let's solve for the D part. So now, in the long run, we use the marginal rate of technical substitute. Of capital and labor. Right. So this is basically equal to the marginal product of labor over the marginal product of capital equal to the rate of labor over the rate of capital. Right. So what we are going to do now is we have to look for our rate of technical substitute. So we have to bring out or fish out marginal product of labor and marginal product of capital and then continue. Let me just draw something. And then bring the cost function. The cost function is yield equals to L raised to the power 0.5 and then P raised to the power 0.5. In this, our marginal product of labor will be equal to, we are differentiating labor in this function. So we are going to get 0.5 L. Then 0.5 at the power will be subtracted from 1. So now it will be, so left is negative 0.5 at the top, then K 0.5. Right. Then now we also look for our marginal product of capital. Meaning that we're also looking for marginal product of capital here in this cost production function. So with this one, we're also getting this 0.5 for multiply with, so 0.5 L is equal to 0.5, then K raised to the power 0.5 plus 1 on subtract. If I'll break this down, all right, let's do this 1 for example. So marginal product of labor is equal to, now the difference between the labor, so 0.5 from the power will come and then multiply labor. Will come and then multiply labor. And so L Then now the power raised here will be right. So 0.5 minus 1. And 3 raised to the power 1.5 since we didn't do it. And the reason why K is still standing is because K is attached to L. It is multiplication. If K was to be plus, we wouldn't really focus on that. We wouldn't even bring K into this function, right? So now we are going to get 0.5 L raised to the power negative 0.5 K 0.5. So that's it. This is the same thing you will also be doing for MPT. The same thing. You don't need to do the same box. Right. So now let's move on to whatever we are doing here. Remember, wage is equal to what was wage? Wage is equal to 4, and rate of capital is equal to 5. Right. So now MPK MPL is 0.5 0.5 L equal to please on times given um, right all over 0.5 L 0.0 0.5 is negative, so right, which is equal to 4 5. Right, so what we are going to do now is we can simplify and then cross multiply. So let's simplify this. So if we have to simplify this, for example, 0.5 will cancel the 0.5, right? And then now you have at the numerator L raised to the power negative 0.5, and the denominator L raised to the power 0.5. So indices, since we all have the same base, we take one and then work with the power. So negative 0.5. Since it's division, we are subtracting minus 0.5. Right. Now let's deal with K2. K2, they are the same base, but they are the same base. So what we are going to do is we are going to take 1 and then so let's bring down multiplication. So we are going to take 1 okay. Take the power there. The numerator has 0.5 minus into bracket minus 0.5 since it's a division. going to amount 4 over 5. So now what is going to happen here is that we are going to get always a power negative 1 times k, right? Which will be equal to 4 over 5. Right. So what is going to happen now is that because L is raised to the power negative 1, L will come down as a denominator and then K will be at top. So K over L. If K were to be raised to the power negative 1, then K will be down and then L will come to the top side. Get it? I think it's like the is going to be 4 over. Right. So now we cross multiply. This will multiply this, this will multiply this, and it will give us 5K equal to 4L. We make one of them the subject. Let's make K the subject. The Bible said that 5. Then K is equal to 4L over 5. It looks plenty here. It's not easy like that. So now we are getting this right as K. So what we are going to do now is, because we are targeting some kind of output to produce for 50, because we are producing 50 units, right? So we are going to substitute K in the production function and then check how we can produce this, because the question was saying that suppose the firm is now free to choose any level of capital and labor to produce 50K of output. How many units of capital and labor will it choose? What is the total cost of producing 50 units? So we are going to look at the optimum capital and labor it will choose, and then the total cost of producing the 50 units, right? So now we put it back in the production function. So production function is Q equals to L raised to the power 0. Only 2 questions then. So L raised to the power 0.5 now times K raised to the power 0.5. That is the production function, right? So now we've gotten K to be what is K? K is 4L over 5. And remember, we are saying we are producing what 50 units. So 50 is equal to L 0.5, where K total. So now K is 4L 5. Right. So what we are going to do now is I'm going to expand this. And then we are going to get something like L 0.5 times 4 over 5 L, right? So root within 0.5 5 points. Right? Now here will be 0.5. Then here it will be 0.5. Or to be that by 0.5. Right. So now what is going to happen here is 50 is equal to 0.5. Now it's a 0.845 times this mathematics. This is just mathematics. So times L 0.5 times 4 over 5. Right. So now we can let L standard number right? 4 over 5 is the answer. Zero point 5. So automatically here it's cancelled. And here indices they are multiplying. So we take the base and then we take one base and we add the powers. So now we are going to get L, let's say 40 because 0.5 plus 0.5 is 50 over 4 over 5. When we do this on the calculator, 60 divided by so we are getting L to be 55.90 approximately. Right? So we now substitute into the production cost function. We now put K, we now put L equals to this in the cost function, right? Okay, so now we still end up at the same thing. So we can now let's make all the subjects with the same. So if we have to make all the subjects with I'll be in the subject. We are going to get this will multiply back. This will multiply back. Right? So L 4L is equal. So 4L will be equal to 4L will be equal to 5T. Right, divided by 4. So L is equal to 5T. 4. Right. So now that's it. So now since we found for L, right, you can use this equation. You can use this what we solve for K is equal to L, the 4L over 5 to look for L. Solve for L. So K is equal to 4L over 5. And then now we find L to be 55.90. So K is equal to 4, 5, 5, 3. So it's calculator. So we are going to get 44.72. That would be for K. So the question was that what is how many units of labor in capital will the firm use? So the firm will use 44.72 units of capital. Okay. And then 55.99 units of labor. L. Right. So now they went on to ask us what will be the total cost for producing the 50 units, right? So now remember K remember the price of labor in capital, right? The price of labor is 4, and the price of capital is 5. Right? So remember the total cost function that we use, which is R K plus. Okay, yeah, that's what we are going to say. So R here is 5. Then we are using 44.72 units plus labor is 4, then 55.9. In total, calculator, sharp. We are getting 447.2. That's our total cost. The total cost of producing the 50 units is 447.2. All right, so you are now done with question 2. All right, that's it for questions. Very good. Okay, yeah, I've remembered. So now we use the normal MPK, MPL over MPK is equal to labor times. We can use Lagrange. I don't know if you understand it though, by Lagrange. For Lagrange, what you have to do is you have to determine your objective function and then your constraint, like objective and subjected to constraint. So this is what it will be like. So remember, remember that our cost function was normally our cost function is CQ, or let's say Q, right? It's equal to 4L plus 5K. Remember, right? 4L, the 4 here is W, and then the 5 here is R, right? And then that's our cost function, total cost function. And then our production function is equal to L 0.5 plus K 0.5. Right. So now remember that we are trying to produce 50 units. So now the 50 units will be our constraint function. It will, like we producing 50 units to make the production function our constraint function. If we were to be producing at a budget of, let's say, $100, then it will be that since we've allocated a cost to it, our cost function will become our constraint. Since we are producing 50 units, the production function will now become our constraint. So now what you are going to do under Lagrange is that you have to define your cost function. Okay? You have to define your objective function, then you subject it to your constraint function. So what it's going to look like is like this, right? Our objective function is CC, which is the same as the CQ, right? It's equal to 4L plus 5K. This is our objective, right? And then our constraint will be, here we are producing 50, so 50 is equal to L raised to the power 0.5 plus K raised to the power 0.5, right? So now this will turn to as our constraint function. Okay. So under Lagrange, once you're able to find your cost function and your constraint, you are good to go. It's it is straightforward from there. So what you are going to do now is you are going to add your objective to your cost function and then equate it to 0, right? You are going to do that and equate to 0. But before you do that, because your constraint has 50 at the back, you are going to bring 50 inside. So let's rearrange the constraint. So now your constraint will now tend to L, right, raised to the power 0.5. So 0.5 plus K 0.5, right? 50 is outside, so when it comes out, it's come negative. It's positive outside, so now minus 50. Now because we've brought this inside, we've moved the 50 outside of the equal to sign into this, and we are equating everything to 0. What we are going to do now is we will introduce lambda, right? We introduce lambda to it. We will bring lambda here to multiply everything. That's basically what it is. So now we are going to add our constraint function and then our objective function now after bringing lambda. I know this will confuse, but once you practice this, you even like the Lagrange own than the first one. So now this is what we are going to do. I'm going to add this one, what we just did to our objective function. So plus the objective function is 4L plus 5K. That's what we are going to do. So now after doing this, we are going to differentiate the labor and capital in this, right? And then we are going to equate them to 0, right? So let's do that. So let's differentiate. What we are going to do is differentiating lambda with respect to labor first. Let's do that. And this is going to give us wherever we see labor, we are going to differentiate. So 0.5, we are going to differentiate this 0.5 L right, and then now the top now will be left with negative 0.5. And then what again? We have L here again, right? We have L here again. And then wow. Maybe it's not error rate. Remember this is not class. Sorry, it's not location. Here, here multiplication. Sorry, we are going to get the 0.5. Right. And then we have this one to do, so class 4. Right. So what is going to happen is that lambda will join them. Lambda will join the family. Was within the lambda was one. Because lambda is multiplying everything, right? So lambda will still come out of it. Down the way. Then now we equate it to 0. Right. So now the same equation appears. And the same, I think if people will not use this one. For me, I find this one easier than the first one. So now from the same equation, now we are going to differentiate. We are going to differentiate lambda. Now with respect to k. Right. So we are going to bring lambda out again. Right. And then now we are doing it for k. So 0.5, we have k here. So 0.5 L, because this will come and multiply, this 0.5 will come and multiply the L. And 0.5 L raised to the power 0.5, right? Then k a with the power negative 0.5. Then we have 5k here, which is plus with plus. And we differentiate it, we are going to get 5. So this is what we are getting. Then we equate that one to 0. The reason why we are keeping long is because of the differentiation. You have to just keep an eye open before you make a mistake, because once you make a mistake, it's really worry. So now just simplify. Let's simplify this. Right? Let's rewrite it in the sense that let's move it to sense. Remember at the top side we had lambda 0.5 L raised to the power. That's the okay. So what we are going to do now is we are going to just write the same thing, but now we eliminate the 0. So what we are going to do now is lambda lambda 0.5 0.5 L negative 0.5 K 0.5. Then now we equate it to negative 4. We are sending the 4 outside, right? So we do same thing for the other one. We do the same thing for the other one. We do the same thing for the decay. So now the same thing. We are getting 0.5 is the power, sorry, 0.5 L 0.5 L which the power 0.5. That's what the that's keeping the parts of this using this out of no 0.5 now. Then now we put it to negative 5. So now this is what we get, and then straight away we divide. So you can see that from here, you remember it was MPK is equal to 4/5 also. MPL over MPK is equal to 4/5, right? You see, we've gotten the same thing here, even when we've not been given, like we've not used 4/5. So there are some questions, maybe they might not give you the okay, no, they gave it to us, and it is in the question, so it is still the same. So now we divide them, right? And then this will cancel out. This negatives will cancel out. Now the lambdas will cancel out, right? So now 0.5 and 0.5 will cancel out. L is here, and L2 is also at the top here. So we take only the base, or we take one of the bases, and then we subtract the powers. So now we are going to get L 0. Negative, and negative 0.5 minus negative 0.5 is going to give us negative 1. So you see we had the same thing, right? And then now K is 0.5 up here. We take only 0.5, so we are getting K raised to the power 1 is the same thing. And we are getting 4/5, just as we did. So what you are going to just simplify and then divide them, right? So when you simplify and divide them, then let's move on. We are getting the same thing. Remember, we are getting the same thing again, right? K over L is equal to 4. This. And then we do the same thing again, right? We do the same thing. It will be equal to 5 T is equal to 4 L. If you want to make K the subject over 5/5, K is equal to 4/4L/5. That is Lagrange. So you see, for me, for example, Lagrange makes the thing simpler. Look at, like, maybe you'll be thinking that if you master this, you wouldn't even waste long time like what I just did. It is just a few minutes. Compare it to this one. That we are going to do a whole lot of stuff. Did a whole lot, right? I just look at Lagrange, just some few steps, and then you are done here. Right? So now you put K into the. You are going to put K into the the constraint function, right? Because that's what we are using. We are looking for what we can do to produce 50 units. So you are going to put k into that function, right? And then that function is 50, right? Is equal to L 0, I mean 5 k k 0 0.5 centimeters. Now we have k to be 4L, the same thing as we did, right? We will just continue from what we did up here. What we did at up here, right? So you see then replace the k into the distance, right? Place k in it, and then we are done with that one. Then we come and then substitute everything again. So just like what we did here. Now you can continue from here using Lagrange, right? Hopefully it's not difficult, right? The same thing. I don't want to waste time with that. So since we have this and you have L here, we have the just come and substitute into this name for K. When you are done, when you find K, then you come and then put K into this equation and look for L. Right? You get everything, then you are done. That's for Lagrange. And I hope this is helpful. Wow, that's good. Very much. Let's move to the next. Let me try to calculate this one. Oh, within the next 30 minutes. See them. Maybe anything here. So now let's read question 3. The Investor Locks Limited, a small producer of motorcycle tires, has the following production pricing based on that. The firm can sell its output for 4 Ghana cedis. The price of labor and capital is 5 Ghana cedis and 15 Ghana cedis respectively. What is the marginal product of labor and the marginal product of capital? Determine the levels of capital and labor using each firm's operating budget of 100. So like here, for example, if you want to use Lagrange, now your constraint function is going to be your cost function, right? Calculate the firm's total profit at the optimal level of capital and labor. If the price of labor went up by 20, will the firm be producing efficiently? If not, explain what the firm can do. So let me do this quickly. Don't waste much time on this. So now, let's your question. Wait. Right. So question 3, you are telling us this, we should determine the marginal product of labor and capital. So marginal product of labor, we are going to get, since the cost function is equal to 60 to 0.6 or 0.4, right? And they are telling us that price that they are selling the things for is $4, and the wage is equal to $5, and then the rate is equal to 50. Right. So marginal product of labor, marginal product of labor is equal to the QPL, since we are going to differentiate what is in here. We are going to differentiate this. Now 0.4 will come and then multiply 60. So it will give us 24 raised to the power 0.6. Then here will be minus 1. L minus 1. L raised to the power 0.4 minus 1. To give us negative 0.6. So that's NP. Now let's go to NPK. NPK is equal to PQ over PK. It is giving us 0.6 times this, and this, 36. K raised to the power negative 0.4 L 0.4. So this is the marginal product of labor, marginal product of capital. Right. Let's move on. And then they are telling us that the second part, so this is 8. Let's move to B. B is telling us that we should determine the optimal levels of capital and labor using a labor usage if the firm's operating budget is 1,000. So if the firm's operating budget is 1,000, so what they mean is that DC, what they technically mean is that total cost is equal to 1,000. Right. We know total cost is equal to the wage times L plus R T. The total cost is 1,000 is equal to the wage is 5 and the rate is 15. Right. So we know that in the long run, as we know already, marginal rate of technical substitute, the rate at which we can change one for the other. So marginal technical substitute is equal to MPL over MPK is equal to equal to W over R is equal to, we find the marginal product of labor. We found it already. Have marginal product of labor to be 24K, 24K 24K raised to the power negative 12 power over 36 K negative 12. All equal to the wage is high about 15, right? So now you can do this 12 to 24, 12, 3, 26. Now case here. We take one of them. So now we are getting 2 over 3 K 1, then negative 6 minus negative 0.6 minus negative 0.4 is giving us L negative 1. I hope we get that. For the first part being K raised to the power 1, we take one of the base because they are dividing, and then we add the powers. And we subtract the powers because it is division. We subtract the powers. So 0.6 minus 0.4 is giving us 1. And the second part, the L2 is negative 0.6 minus 0.4. That's negative 1. So this is what we are going to get. So we are going to get, and I've told you that since 5, and this one's so we are getting one of that. Right. So now what we are going to do now is, since L is having a negative here, L is coming to join 3 down. So 2 K over 3 L. Because L is having negative at the top. 1. So now you can cross multiply. Six K equal to 3 L. Right. So if we want to make any of them the subject, so let's say we are making K the subject over 6, but 6 K is equal to 1 over 2. So put 1 over 2 L into the put it into the cost function. So now this is the cost function of, if it's equal to, okay. Nice. W here was 5. FL plus 15 times 115 divided by 2, so 7.5 L. So what we are going to do now, so we are going to get 12.5 divided by 12.5. So we are getting L to be. So L is going to be 80. Right, so we put L equals to 80 in the same equation. So technically, if L is going to be 80, then we can substitute and then come and put L here is 80, right? Which will give us K will be equal to 40. Right, so now L is equal to 80, 40, right? So now as the question asks, what would be the optimal level of capital and labor if the firm is operating? So now the optimal level of labor and capital that the firm will be operating is optimal labor 80, optimal capital 40. So just add some English to it. That the optimal units of labor that the firm will be using, maybe the question. Okay, the optimal level of labor that the firm will need to produce at a budget of at a budget of $1,000 is 80 units of labor, and then you do the same thing for capital. Right? So now you say calculate the firm's total profit at the optimal level. So now let's calculate the firm's total profit at the optimal level. So to calculate the total profit at the optimal level, what it will be is that we know that profit equals total revenue minus total cost. Right? Total revenue is equal to P times Q. Total cost is um total cost is 1,000, because that was what the budget is. Right? Now we don't know Q. So we have to look for Q. So now the production function here is, let's look for Q here. Right, we use the same production function, which was 60 P 0.6 L 0.4. Right? The same thing. So we now come and substitute whatever we had. So let's say K was 40. Then L was 80. So we are going to get 166.82 limit. Now, the price they were selling us is at 4, the question, times Q is now 166.8 minus power, which is going to give us 126.7. Right. This is what we are going to get as profit. Internal profit. Right. So this is it at this point. And then now the D part is if the price of labor went up by 20, would the firm be producing efficiently? If not, explain what the firm can do to produce efficiently. So basically, if I don't want to teach the Lagrange. If I'll be teaching the Lagrange, then I shouldn't, because it is taking all the time. So if the firm is producing, so now if the firm is producing, if for us to know that a firm is producing efficiently, what is it? The price is going up by 8. Will the firm be producing efficiently or not? So now, so if price of labor went out by 20, right? So initially, labor was 5, and then now it has gone up by 10, so it's now 25. Right. What we are going to do now is we find the marginal product of labor and marginal product of capital. So in a sense that the efficiency rate, right, for a firm to be producing efficiency, right, for a firm to produce efficiently, marginal product labor all over wage should be equal to marginal product capital. This is for this is when a firm should, if a firm should be producing efficiently, it should be equal. So if one of them is bigger than the other, then the firm is not producing efficiently. So let me and then solve this here. So our MPL is solved at the later in the beginning. We had 24 a 0.6 L negative 0.4. So 24. Now let's exchange the figures that we had for figures also. K was 40, and then 0.6, and then L was 80, negative 0.4. Then we have See, the NPK. Our NPK was 36. So L make L raise a power 4. And when you put everything inside, F is K is 14. L is 2. Right. And then we are going to get 47 and 5. 5. So now let's come back to the question. MPL is 15. Coins, goods, and our weight has gone up, so our weight is now what? 25. Now, MPK is 47.5. And then marginal product, the rate of capital was, I think, 16 or so. So let's check which one is bigger. So solving, we can see that marginal product of capital is bigger than marginal product capital over the ratio of marginal product of capital to the rate is greater than the ratio of marginal product of labor to the weight. So now, this basically means that the firm is not producing efficiently. The firm will only be producing efficiently when they are the same. As since they are not the same, the firm is not producing efficiently. So, firm is not producing efficiently. So now they are asking us, what, if not, explain what the firm can do to produce efficiently. So what this means is that the firm using more capital in production is more efficient than using labor. Now, what the firm has to do to produce efficiently is that the firm has to use more of capital, right? The firm has to employ more of capital. And as time goes on, capital will reduce the value, the ratio of marginal product of capital to the rate will reduce to its terms and then equate the ratio of marginal product to labor, marginal product of labor to the weight, right? So basically what it means is that since it is more efficient to produce when using more capital than labor, the firm should employ more of capital now, right? So as time goes on, the usage of capital will now fall and then to come and then equate to come and then equate the ratio of marginal product of labor to the wage. I'm sure you understand this. So here it's basically saying that this is more efficient, right? So let me show you the control. Let me use Lagrange here. It's Lagrange. Yes. Let me use Lagrange on this. So Lagrange on this, for example, will be we have our Lagrange. So we have our U to be so by this time, who is calling me? Hey. So U is 60, 0.6, L 0.4. And then now our cost here is 1,000 is equal to 5L plus 15 X. Right. So since there's a budget here, this becomes our constraint. And here becomes our objective function. All right, so what we are going to do now is we are going to bring 1,000 inside the distance and then lambda it. So now it's going to be 5L plus 15 P minus 1,000. Right, all multiplied by lambda. That's all. Right. So now we are going to add then we're going to add the objective plus the constraint plus right. So now it's looking like this. What we are going to do now is we are going to differentiate L so going to differentiate lambda with respect to L. Right. So if we are doing this, we're differentiating this. Now we will get 5 here. And then we are differentiating this. So we are going to get 24 3 6 move it to right. Then now let's differentiate the other one to 3L. Then we are going to get sorry, differentiate and then equal to 7. So now BL are going to then BL of the 7. So basically what we are going to do now, we are going to differentiate the key. Let me get this here. Then we are going to this class 36 and this and everything outcomes. L L 0 4 0. So now what we are going to do is to simplify them. So now I'm going to get 24, we simplify and divide it. So 24 is 0.6 negative 0.6 is equal to, this is positive, so it's positive to come negative 5. And then divided by 30, so 36 to negative 0.4 L 0.4. So both of these positive represents so negative 2. Remember, it's similar. It's similar way, it's same thing. 5 over 15 is we have negative 5 over negative 15. The same thing. 24 at the top. The same thing. If you can see. If you can see this. Right, they are the same. Just that Lagrange makes it more easier for me. Right. So from here you can continue the same thing. Right. So let's move on to the last question of this area. To tell that we used all good hours to solve. So we are done with question 3. And I said question 4, we solved it on the market structure with just system. So I'm not going to do this system again. Right. So let's solve question 5. Question 5. Don't forget to like and subscribe. I'm very tired, but that's it. All right. So most, and I read most weeks, demand for roses can be approximated by quantity demand is equal to 2,400 minus 50p, where QD is the total quantity demanded in doses at price P per dozen. And the roses are supplied by identical 50 US. Each having total cost of 0.25 Q squared plus 0.5 K plus 20, where Q is the number of roses supplied by the grower. So each of them have this total cost. And the $20 cost can be avoided on a daily basis. So meaning that the $20 cost is more or less like a fixed cost. Okay. So please asking what is the short run supply for each individual grower? Describe the curve both algebraically and graphically. Then B, derive the short run supply schedule, which gives quantity supplied as a function of price. And then C, what is the equilibrium price for a dozen roses in the market? And 4D, so assuming there is free entry in and exit from this market, would there be entry or exit from this market going? What am I? Assuming there is free entry in and exit from this market, would there be entry into or exit from this market going into the long run? Explain the answer. So, if you can look at this, they are telling us that currently rules are being applied by 50 identical growers in and what? A perfect competition market. You're in a perfect competition market. Remember perfect competition market, right? For perfect competition market, the uh, the producer will supply only when MC is equal to MR, right? And it's the same as MC is equal to is as MC is equal to A and the like. The same as B, right? So let's let's enter into this. We just did this just yesterday. So or just the previous video. So mainly question 5. Question 5, what we are going to do is that we have our quantity demand. QD is equal to minus C. Right. And then the total cost function is equal to 0.250 square plus 0.50 plus 20. And remember, in the perfect competitive market, just spoke about it yesterday, that producers supply when price at equilibrium, right? It's at equilibrium. The firm only produces when MC equals M. Remember that I told you MC is equal to M. That's what the firm only produces, right? And then in perfect competition market, MC is what? The MR is also equal to P. It's also equal to AR, right? If you don't remember, kindly watch it. Right, so that's what we are going to do. What you are going to do now is you are going to find marginal cost in this total here, right? Total cost function. So marginal cost will be DCC here, right? So we are differentiating the rate. So here, for example, here is here. So 2 times 0.25 is giving us 0.5. So 0.5 here plus 0.0.5 right? So that is it. This is the end. So this basically means that MC 0.5 plus 0.5. Remember yesterday, so we want to derive the Finc supply function. We find the NC and then we equate it to P. Remember, just did it yesterday. So now we equate it to P, right? So NC is equal to P. MC is equal to P. MC being equal to P. MC, we have MC to be 0.5 Q plus 0.5 is equal to P. Right. So if we want to get a quantity supply 0.5 0.5 Q is equal to P minus 0.5. This is let's double head by 0.5 to get quantity supply. So we are going to get here is equal to 2 minus 2 minus 2 minus one. That would be our quantity supply, right? So we're able to derive a short-term supply here. So we are going to say that it says what is the short-term supply describe the therefore the short-term supply uh, so the same we should do this graphical logic. So graphically, what we are going to do So we've done it. We've done this graphically. Now we have to do this algebraically. Okay, we've done this algebraically. Now let's do this graphically. Now it's going to now let's for P when Q is 0. So when Q is 0, right, so Q when Q is 0 equals negative 1. And then P when Q is 0, Q will be equal to okay, so this is going to be a good value. So Q will be equal to negative half. I don't know if you get it, because we did something like this, the mass of light. So what is going to be that when this is 0, and this is 0, it's 2Q cross, then it look like 2P is equal to, okay? If I don't give the 3 put, so negative 2P is equal to negative 2P, to give us positive 1 over 2, which is so so let's just assume that there is negative 1 x up. Let's trace here. Let's also find here. Right. So we've done this both algebraic and then graphical. So now, write the short-term market supply schedule, which gives quantity supply function as the price. Then derive the short-term market supply schedule, which gives quantity supplied as a function of price. All right. So this means that we have to derive the market supply function, right? Basically, individual supply function is individual supply function. So the first part of A. So the individual supply function individual supply function is 2, 3 months. So right. So now they said there are 50 identifiable people here. So you have to multiply everything by 50. So that we'll get the market supply function. So now we are going to get 50 times 2p is going to give us 100p. Right. That is the quantity. That is the market supply. That is the market supply. Right? That's market supply. So here they say that the market supply is kept. So now let's go to C. C is saying that what is the equilibrium price for a dozen roses in the market? Now we know that at equilibrium, right? Quantity demanded is equal to quantity supplied, right? And then for this C, okay, quantity demanded is equal to quantity supplied. So our demand here is so our distance is 2,450. 2,450. Power quantity supplied is 100 to minus 50. So 2,400, everything like the 50 to make plus. So now we are going to 4, 5, 7, 3, 4, 2, 1. About 1, 2, 3. So 3. So we are getting 16.3 as price, right? So now we put price into either supply or demand, and then we get our Q. So now let's put it in get so Q equals to 400. 400. 50, 20. And I'm getting two, three. So, so here is equal to 1, 2, 3. So the equivalent price is 960 years is what is the equivalent price is 16 this equivalent quantity is this. Right, so it's not like this. Five, 9, then that will be 158%. Not really each. So it says assuming there is free entry and exit for this market, would there be entry into or exit comparison going into the long run? So what we can do, remember that for us to know whether firm will leave or will enter into the market, it's either they are influenced by trade incentives or losses. So profits will make firms to enter into the market, whilst losses will make firms to leave the market. So that's basically the same thing. So let's do that. So let's solve for the profit for this market, right? Solve for the profit, and then we solve for the we solve for profit, and then we solve for profit, and then we know whether they are making profits or they are making losses. We move on from that. So now, what we are going to do now is we are going to solve for profit. So now profit, which equals revenue minus total. Right. Remember that they can only raise revenue from what they supply. So now price is 16 and quantity is equilibrium quantity price is 60 and equilibrium quantity 15838. So now what we are going to do now is this. But here we are going to use the equilibrium price and quantity. So all we need to do times route total cost is what has been given to us. Total cost function is right, I'm sorry. Total cost function is 0.25 kilo square plus 0.5 kilo plus 20. So now price and quantity. So into bracket 16 to 30. 1, 5, 8, 3, 3, 3. 0.25 bracket 1, 5, 8, 0. So 6.00. We are getting to 5, 8, 9, 9, 10, minus 7, 7. Oh my goodness. Five, 6, 7, 12. And then plus 2, that's to 2, 5, 8, 5, 2, 5, 8, 7, minus 6, 7, 5, 5. Negative. All right. Think our project is it's been somewhere on the perfect outside of school. And next friend with some style. Right. So right. So basically, what we are going to do now, when we're being taught, we're like we should rather solve for the individual supplier. So we solve for the total revenue. We are going to solve for the total revenue for the individual suppliers. So which is basically remember it was Q equals to 2P one. Oh, I've not read out my book, so let me just look. So 2, 3 minus 1 index. Now we had P to be. Remember, the equilibrium quantity will be there, but that doesn't mean that firms are going to supply the equilibrium quantity before the firm, before other firms can either exist or in an industry, right? Firms in the industry are supposed to be making profits or losses, not the whole industry are to be making profit or loss. So now what we are going to do is we are going to put E is 16.33 into this equation. So now Q is equal to 2 bracket 6.33 minus 1. This is going to give us 31.66. Right? So now Q is 31.6. So this will make total revenue, which is equal to price and quantity, right? Is equal to 30 because here is Q, the quantity supply in the each firm supplies. So Q is equal to 31.66 times 16 point. And we are going to get 517.01. That's what we are going to get. Looks out. So let's go ahead and do solve for total cost. TC is the individual extenders. Because if TC was being given for an individual formula, the TC is equal to 0.25 square plus 0.5 plus 20, which is going to be 0.35. That's just 6. It's 1.66 plus 0.5. That's the final. Then the base. I'm sorry. What in that show the base? This one. This show. We are getting 286.43. So now profit is equal to CRT, right? So we had total revenue to be 517, CC to be 286. So we are going to get 0.5, right? So this basically means that it's going to be entering into the market since individual firms are making profit. So if individual firms are making, this is a profit. If individual firms are making profit in this market, then other firms are going to come into the market and compete until this profit, this abnormal profit turns to normal profit, right? Yes. So basically, this is where we end this tutorial. I know this is a long video though, but I think it's worth it. Yeah, it's worth it. So don't forget to like and subscribe, right? Thank you very much for watching this video. And I hope it was insightful. In case of any question, you can reach out to my DM 0244 now. Then I will give you an explanation, right? Only if it's about this, I'm sure I can explain. So all right, see you some other time. Bye. No, not bye. Let me scroll up and then so that you can check. All right, see you some other time. Bye.